Now we're going to look at properties of real numbers. So let A, B, and C represent real numbers. So all of these properties down here have names, and you may be familiar with them or not, but you will need to know these. So the first property right here, that if A plus B is a real number, so that's if I add, if an A is real, B is real, when I add them together, it's a real number. That is called the closure property. Closure property. Okay, so more specifically, this one is the closure property of addition. This one is the closure property of multiplication. Let me just clarify exactly what closure means. Many of you know that if you take 2 plus 4, in other words, an even plus an even, you get 6, which is an even. So we know that if you add even numbers, you will always get an even number. So we would say adding even numbers is closed because it gives us closed, it always gives us an even number. But adding odd numbers does not work. Watch this. 3 plus 5, that gives you 8. So here we have odd plus odd gives you even. So this is not closed because it goes outside the system. But real numbers, if I'm adding real numbers, then I will always get real numbers. And if I multiply real numbers, I always get real numbers as well. Okay, the next one is called the commutative property. Just like you see the word commutative property. And more specifically, commutative property of addition says that you can switch the order and the value will be the same. Same thing here, switching the order, A times B, B times A. Of course, an example of that, we know that 3 times 4 is the same value as 4 times 3. Now, we're not saying practically it's the same thing, right? Because if I have 3 rows of 4 versus 4 rows of 3, they're different scenarios, but we end up getting 12 no matter what. So the value, not necessarily the concept behind. So that's called the commutative property. All right, the next one is called the associative property. Please don't abbreviate like so. If you are going to abbreviate like so. But spelling it out is the associative property. More specifically, of addition says that if we're adding A plus B plus C, it doesn't matter if I add the A plus B first or if I add the B plus C first. Technically, we can move things around and add the A plus C first as well, but associative, since they're next to each other, we can group, okay? So, and the same thing here, multiplication. It doesn't matter how we associate the pairs, just as long as we get them all done. The next property here is called the identity property. Identity in numbers is a number that doesn't do much, right? So the identity itself in addition is 0, because when I add 0 to any number, I get that same number. The identity in multiplication is 1, because when you multiply by 1, it doesn't change the value. So the identity itself, the number 0 or the number 1, the identity under addition, the identity under multiplication, doesn't do anything. And that's actually a very powerful thing, because it exists, but it doesn't change the value under this operation. Every other number will change the value. So that's called the identity property. And the next one is called the inverse property. Again, the inverse property of addition says that if you add 2 numbers together, you get the identity. So notice here we are. So if I have 2, what do I add? Well, if I add a -2, I get 0. In other words, adding opposites will give you 0, but that's called the inverse property. And over here, the inverse property, if I have A and I want to get to the identity, in other words, cancel things out, we often say, or reduce it. So if I have 3, then I need to divide by 3, right? That'll give me 1. Again, why is that important? Because we know that when I have something like 3A equals 9, I can use the division property to divide both sides by 3, but then I'm using the inverse property here to reduce it to 1. So I only have 1A left. So it's a very valuable property, although it's very simple. Most people say, oh, I already know that. Okay, and the last one, of course, can work under addition or subtraction. It's called the distributive property. And distributive property is exactly what it sounds like. The outside term gets distributed to every term on the inside there. All right, so walking through which of the properties here is being illustrated. And we're going to be specific, so I'm going to say two things. Number one, the closure property of either addition or of multiplication. So let's do all of that. So this one here, let's see what's happening. I have a 2, I have multiplication, I have sum, I have parentheses. Oh, but look, now I have two 2's. So just to clarify that, I have one 2 there, but two 2's there. So what's happening? The 2 is being distributed. So this is the distributive property. If you want to abbreviate like so, you may do so. Okay, so here I have a -7, and I'm multiplying it by a -1/7, and I get a 1. So clearly that's going to be the inverse property of multiplication. So I'm going to call that the inverse. You may abbreviate like so, property of multiplication. And if you want to use a multiply like that or write it out with a mult, you may do so. All right, continuing on here, let's see what happens. I have a 16 in front, and then the 16 at the end, a -3 at the end, and -13 at the beginning. So essentially what we're doing, we're commuting the terms. The terms are going back and forth, commuting. So this is the commutative property of addition. Again, if you want to abbreviate, you may do so, like so. Commutative property of addition. All right, and this last problem here is we have a pair of parentheses combining these two numbers, and then we have a pair of parentheses almost as if we shifted it that way. And so there we go. That's the associative property of multiplication. And now on the last page, this is a little bit of practice. Again, you're going to do what we just did. You're going to name the property of real numbers illustrated here. And let me walk you through what each one of these is down here. So we'll do one of these together. Classify each variable according to the set of numbers that best describes its value. So, for example, the air temperature in St. Paul, Minnesota measures to the nearest degree. So that's a key thing, nearest degree. And maybe something you need to know also is that it gets very cold in Minnesota, okay? So if we were saying something like Florida, South Florida, then there's a good chance that would always be warm, and it would probably always be positive numbers. But because St. Paul, Minnesota gets cold, we have negative numbers, and we're doing the nearest degree. So we're going to do essentially whole numbers, or better yet, integers. We're using integers. And so there we go, because it can be the positive or the negative integers. It can get all the way down to something like -40 degrees, or it can go all the way up to maybe 100 degrees. I'm just making up. I honestly don't know the actual average temperatures. So that's what you're doing here. You're figuring out which is the best set there. And lastly, you're going to estimate what number this is. So for example, point A is pretty obvious, but point C looks to be, so here's -4, here's -5. -4.5 is right here, so it's got to be a little bit smaller than that. So -4.75 maybe. That would be a decent estimate there. So I'm going to use this symbol right here for approximately equal to -4.75. And just do the same for the others as well. Thank you very much.